This React app is kind of slow. Hello and welcome. Hi, I'm Dave. Today we're going to look at the React hook useMemo, how it differs from the React hook useCallback, and how to avoid the app performance lag you saw at the beginning of this video. So let's get started. I've got Visual Studio Code here on the left, and on the right I've got Chrome, I've got the app running just here on top, and I've got the DevTools console here on the bottom. Now what we're doing is bringing in an expensive function. Expensive functions could also be referred to as costly or just simply as slow functions. And a very good example of an expensive function is a function that makes use of recursion like this fib function does. So it calls itself inside the function. And we request the position. Here I'm requesting the 33rd position in the Fibonacci sequence, and it returns that number, but it has to go through the calculations to get there. So it takes it just a little bit, and that makes it slow. And when I'm typing my name, I just did, and then it shows up about a second later, that means that equation is slowing down our entire application. So we need to look at why this is and how useMemo can help. So inside our functional app component, you can see I'm assigning fib number the result of fib. And then we're going ahead and placing that inside of the JSX, and I'm showing that output. Let's find it here. Here it is, where it says number, and that's the number we see over here on the right. But it takes it just a little bit to do it, and the further into the sequence I request, the longer it takes. If I request the 20th position, it's fairly quick. The 35th position, kind of slow. So it does make a difference. I just picked 33rd because it wasn't so annoyingly slow that I couldn't show you the example, but it still slows things down. I can definitely outrun it by typing into the input. So now what we want to do is consider how to fix this and exactly why it slows it down. Well, the reason it slows it down is because when I type into this input over here, the random input, I'm updating the state. And we know from useState that every time we update the state in React, that re-renders the component. So every time this component re-renders, it's recalculating this Fibonacci number. Even if we haven't changed the input, even if the number stays the same, it has to recalculate it essentially for every letter I type and every letter I delete. And it's running just a little bit slow behind my typing. So we want to go ahead and speed that up. So that would be the first use of useMemo, is being able to optimize our application. But there is another use, and the second use of useMemo is for referential equality. So I'm going to go ahead and pull the console up and over a little bit just to go over a quick lesson on referential equality. So if I take the number 5, use strict equals and 5, that is true. That's a primitive value. So 5 strict equals 5. The same with string. Strict equals string. True. That's another primitive value. But if we look at an empty object, use strict equals, that's false. It does not have referential equality. They're stored in different places in memory. They look the same. They're not the same. And the same thing goes for arrays, which are also type of object in JavaScript. So arrays and objects do not have that referential equality. And we might get a result from a function that is an array or an object, and we might need that referential equality. And we can also get that from useMemo. Because what useMemo does is memoize the output of a function, not the function itself. That would be useCallback. useCallback gives us a function with referential equality that we can call later. useMemo gives us the result of a function that it calls. So now let's go ahead and look at a couple of examples of that. First, I just want to address that referential equality one more time before we apply useMemo. So I'm going to bring in useEffect, and now I'll put useEffect in here. There we go. Type that correctly. useEffect has a dependency array, and what I'm going to do is put fib number in that dependency array. Now every time fib number changes, we're going to log to the console new number, because that's what useEffect does. It looks for a change in its dependency array, and if there's a change, so if fib number changes, it will call useEffect and will log to the console new number. So now let's come back, clear out the console here, look at our app again. I need to save our changes over here. And now that we've got that, let's put in a new number, and I'm going to put in 33. Still takes it just a little bit to calculate. Now let's look at our console output. And when the app loaded, we got new number, and then we typed in two numbers. So at first it was a 3, and then it was 33, so we got new number twice. That's good. Let's look at what happens when I type in the random input. The app is still slow. It's recalculating that every time, but we did not get new number anymore. And that's because we didn't change the 33 number, and 33, it's a primitive value. So useEffect knows it has a primitive value here that is not changing, and so it's not calling useEffect. And that's before we put useMemo on our fib function here. So when we use useMemo, we're really guarding ourselves for values that are not primitive, that are possibly objects or arrays, for example. So now let's bring in useMemo. And now let's apply useMemo to our fib number value by wrapping this call to fib. So we'll have useMemo, we'll have an anonymous function, and then we're calling fib with the user number state inside of that. And useMemo has a dependency array. There we go, an array, not an object. And now inside this dependency array, fib is outside the functional component. So it does not need to be in there. However, user number is a piece of state, and it does need to be in there. So that is our dependency array for useMemo. Now the difference here, although it won't change anything with useEffect, we found that we didn't have a referential equality problem there because it was a primitive value that was not changing. But we did have a problem with performance. So now I'm going to put 33 back in here. But now let me go ahead and type my name, and I'm typing, and it's showing up just as fast as I type. There is no more lag in our application. And that's because useMemo is providing this fib number, and that is not needing to be recalculated every time. It is a memoized result from our fib function. Now, that did not speed up how fast fib will calculate. It's not a traditional memoized function. It's just memoizing this one value, but that helps our app render quickly, and it eliminated the lag. So while we're discussing this, and I mentioned you didn't need to put fib in the dependency array of useMemo because it's outside of the functional component. Well, what if it was inside? So let's go ahead and cut fib away there, and we'll define it inside of our functional component instead. And now we have a new problem. And this problem is every time the app re-renders, fib is recreated. And so that is a new function. So when we go ahead and stick fib in the dependency array, as it should be now that it's inside the component, we still have a problem because fib is new every time. So once again, our app should now have the lag issue when I save, and I'll type my name, and it's probably, yes, it's slow again. I already typed it, just waiting for it to come. There we go. So now I'll delete it, still slow. Our problem is we need to use callback with fib. As I mentioned, useMemo memoizes the result of a function that is called. useCallback will deliver a memoized function that can then be called. So that's what is needed here. And that's the difference between useMemo and useCallback. useMemo provides a memoized result. useCallback provides a memoized function. So let's wrap our fib function in useCallback. And for dependencies, really it's just an empty array here with fib. It doesn't have any dependency we need to put in there. But now that we have applied useCallback to fib, and fib is in the dependency array, because it's defined inside the functional app component, we don't have any problem with speed now. I can type my name and it shows up just as fast as I type again. Now, if you're more interested in the details of useCallback, I have a separate tutorial on that I'll link to above and in the description below. Now, before we finish, I'm going to paste in one other expensive function. This is just a made-up function. You can see I have it going through a for loop about 1 billion times right here. And then I just say do something expensive. It doesn't really need to when the loop's that long. And then it just returns an array. Now here's the catch. We remember an array is not a primitive value. So this will not have referential equality to the array that it may have delivered before. So let's go ahead and put this into place and see what happens. So we've got get array, and I want a value from it. So I'm just going to call that value my array. Set this equal to get array, what comes from get array. And now let's put my array inside of useEffect here. So instead of new number, we'll say new array, and I'll save. Now I want to be able to see the output of the console a little bit, and yet let's clear it out so we just get some new information here. And we should get a new array. There we go. We got a new array eventually. It took just a little bit to run that expensive function. So now every time that I type inside of the input, I'm updating state, remember. There I typed 4 letters, expensive function. See what we got. 4 times the new array. So every time useEffect said this is something new and I need to run, and that's because an array is not a primitive value. It doesn't have referential equality, but we can gain that by using useMemo. So let's go ahead and apply useMemo to the expensive getArray function. Now getArray is not inside the functional component app, so we do not need to put it inside of the dependency array here. We just need to call it. We don't have any other dependencies, and we can save that. Let's clear this out, and there we go. Refreshed, we got new array when the app started. So now I'll type my name, and it types quickly. There is no lag. We're not waiting on that expensive function, and there are no more logs to the console that say new array. That's because we now have referential equality with the my array value. So useEffect knows this is not a new array. It's the same thing that it was given before. It's that memoized value from useMemo. So I just wanted to give an example of a dependency in this useEffect hook dependency array that was not a primitive value. So it thinks an array or an object would be new every time unless it gets that memoized value from useMemo. Remember to keep striving for progress over perfection, and a little progress every day will go a very long way. Please give this video a like if it's helped you, and thank you for watching and subscribing. You're helping my channel grow. Have a great day, and let's write more code together very soon.